Okay, NRGY 243 PV. It's week 13, and I thought we'd just go and take a little bit of time to look at the NABCEP learning objectives. I think at this point, almost everybody is paid for the fee. Sorry about the $95, but that's kind of what keeps this thing alive. 11 pages. And here we go. Very basic elementary knowledge of photovoltaic systems. Fortunately, we've had a little bit of hands-on. We've got the trailer out back, and there's more of that planned for this summer and the fall as well. We might even run the NCCER course. So again, this is just kind of the first step, get you in the door. Okay. Students taking the entry-level exam will be tested to some degree in all 10 categories. Consequently, in teaching preparatory courses, it's important that all 10 categories are covered. We'll make sure that we've got those. PV electrical system design. Must be taught, okay. So PV markets and applications. I think we've discussed that to a fair extent in terms of where the markets are, where it's sunny, where it's not, rooftop versus ground mount versus large scale. The safety basics, these are going to be almost almost all common sense. I mean, seriously. Electricity basics, you're taking 105 and 106. 105 is going to be all that's really necessary for that in terms of parallel series, Ohm's law, power law. Solar energy fundamentals, we've gone through the solar constant. We've gone through the physics of the PV module fundamentals. We know how photons work. We know how the panels are doped. We know the difference between DC and AC. With the solar energy fundamentals, we know roughly how a solar pathfinder works, latitude, longitude. We've been through all that mathematics. System components, we've been through the modules, the panels, the arrays, the inverters. We've gone through maximum power point tracking, PV system sizing principles. We know the difference between power and energy for sure. There's going to be questions on that in terms of if you've got this many watts per square meter, this is how many square meters you are, this is your tilt angle. Based on the tilt angle, this is going to affect how much energy comes in. Your power, energy, and time equations are going to come in there on the sizing. PV system, electrical design. Again, that's going to be your parallel and your series, your wire runs. There'll probably be a few questions on voltage drop. So depending on how long the wires are, you're going to want to know ohms per meter. The longer the wire is, the greater the drop, to make sure you can get to the proper voltage. Performance analysis, maintenance and troubleshooting. We're going to talk about that a little bit today. The mechanical design, I think we covered that. Let's look at that just briefly. Hit the highlights on mechanical design. Did he cover it? 274? Okay, good. So I'm like, I don't think I covered that much, but as long as Greg did, okay. Well, even last week we were looking at some of Bobo's plans. We were looking at live load, static load, pounds per square inch. you might want to know, on the mechanical design, you're going to want to know the difference between pressure and force. Just know that pressure is pounds per square inch or pounds per, know the difference between those two things on the mechanical system. Yeah, so I don't know, I think we're pretty well prepared. There's really, in our book here, there's a chapter on utility interconnection. That's not even on the exam. There's a chapter on permitting and inspection. I covered that a little bit last week. That's not on the exam. Commissioning, maintenance, troubleshooting, that's basically our chapter 14. Economic analysis, that's not even on the exam at all. So you don't even have to worry about the economics. So really the one last thing that's on those 10 learning objectives that we haven't covered yet, it's right here at chapter 14 of the book. So we're there. If you've hit all the chapters for this course, we're there. So let's just briefly look at this electrical system design below, and then we'll get into learning objective 10. Yeah, this is a great little guide. This thing's fantastic. Yeah. So what I would do in studying, I would go through each one of these bullet points, find where they are in the chapter, in the book, which chapter in the book. Nail it, and just be sure. I've also found, and this will help for the exam too. It sounds like you don't get to take your book in, but is that true or not? Do you get to take your book in to the exam? No book. So when you're in the exam, though, you'll be sort of rehearsed. And if you've ever, memorized a song or some lines of a poem or whatever, it's going to take longer at first, but then once you go, sleep for a couple days, rest, come back, it'll all come back to you. You'll be able to think, oh yeah, it was chapter 2, ding, 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 and like the visual will come back, and you'll remember it. So there's safety basics. Yeah. Oops. We've spent a lot of time doing that. I know you'll be fine there. So power and energy, just to mention that. Yep. Solar energy fundamentals. And if you look at any of these words, you're like, what the heck is that? Look it up, write it down, and then just go back and you'll know it. So like you should know every single one of those words going into it. Critical. So know what every single one of those words means, and even say it out loud. And geek out about it. Tell your wife, tell your kids what it means. Try to explain it to somebody else. Array shading, obviously if you've got a panel in series and one of them shaded, it's going to affect it a lot. Microinverters take care of a lot of that. And even in our new trailer, there's some DC to DC MPPTs that even take it to the next level. I don't think that's going to be on the exam. It's kind of third generation, but it's critical. Go after a little bit of geometry on that so you understand the angles. We spent a lot of time talking about this. We spent a lot of time talking about this. Series in parallel. There we go. STC. Do you know those off the top of your head, Todd? I'm not even sure. What's that? You don't? Okay. Let me, PV module arrays. I'm going to look them up really quick because I'll be honest, those are not, those acronyms do not jump to mind immediately for me. So let's just do a little bit of online research. I don't mind that at all. STC, SOC, NOCT, PTC. Nameplate ratings, Fire Mountain Solar. What do you got? Review, look at that. Okay, let's just see what happens. Nameplate rating versus real world performance. Just click the link below. Usually if I'm trying to find something quickly, just come in here and do Control F, STC. Standard test conditions. Okay, so that's STC, SOC. Don't see that one. NOCT. Don't see that one either. PTC. PV USA test conditions. Yeah. So. Test conditions. There you go. And let's see what it has to say there. Sharps is a nameplate from the testing promotion. Factory PV standard test conditions, which keep the PV test temperature at a nice. So there's 78 degrees in the real world. Even a chilly day, you can see hotter PV. So every single panel is going to behave differently, and I think the thing to know is that the hotter they get, the less efficient they get. So, and they're all going to have their own little band gap. Still not sure what SOC and NOCT are. Let's just take one more look. It might just be on this. Yeah, let's take a look. This is kind of fun. Ebook, huh? NOCT. Normal operating cell temperature. There we go. And then SOC we didn't find either, did we? Oh, standard operating conditions. So it's operating versus test. You're gonna test it in the lab at one condition, and then it's gonna operate in the field at a different one. Okay. Let's just spend a little bit more time on this. System components. Well, and so these are pretty, should be fairly obvious. The inverter is to go from DC to AC. The charger is for charging batteries, and the charge controller is so that the battery does not overcharge, and then energy storage typically is some kind of battery, as you know. So one thing I don't know is whether or not you'll be in the PV Watts software or not, but I know we've spent some time on that in the course. So at least be able to look through a table and look something up. And I'm guessing this too. It's going to be some kind of table. This is going to be able to know your what your battery amp hours are and the volts to get power or total energy. So this is the one that they suggest you spend the majority of your time on. Power flows to the system. Obviously, it's going to, flow into your storage in your house when the sun's up, and the other way when it's not. This one too. Just know your series, know your parallel. Know the difference between resistance. Well, I don't think you're going to know the difference between resistance and resistivity, but just know how to solve an equation so the longer the line gets, the less resistance, or the more resistance there is. Perfect. Basic principles of PV grounding. Yeah, for single point grounding, this is going to be for a given home. The system itself wants to be grounded at a single point. Otherwise, you basically set up a circuit through it. You just kind of want one path to ground. No reason to make a circuit. Don't need one. We've covered this too. The construction contract's a big one. I've got to figure that one out on my own little system right now. Okay, so, and then Guccio covered mechanical. That's the critical portion, so your roof does not leak. Compliance and warranties. I think skills and competence. This is going to be also fairly common sense, and if I'm sure they'll bias it towards NABCEP versus non-NABCEP certified. And this is what we're going to cover today. So this portion critical. Understand the safety requirements for operating and maintaining different types of PV systems and related equipment. We can dig into that a little bit in the chapter. This is also identify the most common types of reliability failures in PV systems. Okay, so again, this is just a review of what the total thing is going to look like, and this is typical. 60 items total. There we go. This will usually require the student to take the exam at a later date rather than immediately following the course. So, you know, again, Todd, if you're not comfortable with it, we can look into having it, you know, having you take it at a later date, but or anybody else for that matter, it's fine. Might not be the easiest thing to pull off, but we'll work on it. So, okay, let's take a little break and then we'll get into today's